Hi everyone. So this is actually my third attempt to record this video today, so I'm not having a very good day. But anyway, let's jump in. So the way this lecture is going to run today is that we're going to cover the last of the inductive argument forms that I mentioned last time, which is the argument from authority. And then we're going to transition into a discussion about the material for about the material on probability that we'll be transitioning to next. So with that said, let's go ahead and jump in. Say hi to Mishka, by the way. All right, so we have all these inductive argument forms that we've covered so far, and we've looked at defeaters for each of them, both undercutting and rebutting defeaters. So we have statistical syllogism, inductive generalization, argument from analogy, and inference to the best explanation. Argument from authority will be the final argument that we cover. So this argument, just as it sounds, draws on the authority of a particular person with respect to the material that with respect to a particular subject. So we oftentimes rely on people who have expertise in subjects to be able to tell us what to do, or sometimes we might want to be able to appeal to what it is that the certain people are saying to try to argue for the truth of a particular claim. And so when we do that, we're arguing from authority. The broad structure of an argument from authority that we're going to be using has the following structure. First premise says just that most of what X believes or says about S, some subject S, is true. P is a part of some subject S, so a statement P is a part of a subject S. Therefore, X says that P, therefore probably P. So in this case, P is a statement that's a part of the subject that X has knowledge of. And what we're doing is we're saying that because X says P, then we should in fact infer that it's true, or at least probably true, that P is true. Okay, so what we want to be able to do is talk about what the different kinds of defeaters are for these arguments. And so the way we're going to discuss this is that we're going to be keyed into what we want to take to be the competence and sincerity of the authorities in question. So the basic idea ends up being that a person is competent with respect to a subject matter if they know how to arrive at true beliefs about a subject matter at hand. Now, how do we know that? Well, we generally have to take into consideration the status and position of the person with regard to the subject matter. So if a professor at a university is teaching you about a particular subject, then you should assume that because they're teaching at that university, like say one of your professors at St. Lawrence, that they have at least some degree of competence with respect to the subject matter. We also have to assume that the people in question are sincere. And so the idea here is that we don't have any reason to believe that they would be telling us something false, or that they have a reason to tell us something false. We'll see some examples shortly that seem to play on that a bit, or where those kinds of considerations may come up. So to search for defeaters for arguments from authority, what we have to be able to do is first, the rebutting defeater is pretty straightforward here. We just have to be able to show that whatever it is that's being said by the person in question is false. So we're just defeating the conclusion by giving evidence that the conclusion is false, and so that even though so-and-so might be an expert in this subject, they're not necessarily saying something true. Even with qualified authority, sometimes it can be the case that they're mistaken about a particular subject, and we need to be able to figure out how to add the information that would show that the conclusion comes out to be false, despite otherwise the reliability of the source in question. The undercutting defeater appeals to the fact that the authority saying something doesn't necessarily lead to the conclusion that we should believe it. And so in this case, what we have to be able to do is bring into question either the competence or the sincerity of the purported authority. And so when we search for defeaters, especially in the undercutting case, we really need to think about the ways in which the competence and sincerity of the purported authority might be important for assessing the argument overall. Okay, so one thing that might occur to you if you're thinking back to earlier in the semester and you're thinking about the informal fallacies we discussed is that we're not supposed to attack people's characters when it comes to giving arguments, right? We're supposed to avoid engaging in character assassination. And what we should do is we should instead try to focus on the evidence here. Now, it might look like in the situation where we're questioning somebody's sincerity or competence that they were in fact engaging in an ad hominem in this way. But we need to be able to distinguish an ad hominem argument from a reasonable vetting of sources. And so when we sit down and really assess the sincerity and competence of an individual, what we need to be able to do is to realize when it is that assessing somebody's sincerity and competence is merely an attack on their character, and when we're actually engaged in the act of trying to see whether that person is a reasonable source of information on a particular subject, on the subject matter in question. So don't worry too much about, like, the idea here is that it is very reasonable to sit down and wonder about whether somebody's character is relevant to a conclusion. In some cases, you don't want to just flat out rely on insults and character judgments to make certain claims. But in some cases, it's really important, especially those cases where we don't have the time or the ability to get into the details of a particular subject matter ourselves. We need to carefully consider whether the person in question has the authority to deliver the information that they're delivering. Okay, so with that quick lesson in place, let's take a quick look at some of the exercises that I've gotten on the authority handout for you. So we've got two sets of exercises. The first says to identify the conclusion of the arguments and say whether the appeals to authority are legitimate or fallacious. The second asks whether the following arguments are ad hominems or reasonable attempts to vet sources. So this goes back to the second issue I discussed before, which is that, well, sometimes arguments are intended to vet sources, and sometimes arguments, sometimes things that look like ad hominems are intended to vet sources, and then sometimes things are just straight up ad hominems. Okay, so let's look at the first couple of exercises, or first three exercises in this first set. So, I'm a doctor. I have a PhD in Middle Eastern Studies, and I assure you that eating that mushroom is entirely safe. Okay, so clearly the conclusion is that eating the mushroom is entirely safe, and the basis for believing that it's entirely safe is that this person claims to be a doctor and has a PhD in Middle Eastern Studies. So they are a doctor in a sense, right? They're a doctor in the same sense that I'm a doctor. Okay, so the question is whether this is an appeal to whether this is fallacious. It seems to be. The reason that it seems to be fallacious is that having I guess, whether a mushroom is safe to eat is not something that would be known necessarily by somebody who has a PhD in Middle Eastern Studies. They might know a lot about the certain regions of the world and the cultures and the past about those I guess the history of those parts of the world, but they're not necessarily in a position to know anything about mushrooms. They would have to have a different specialization to serve as a reliable source with respect to that. So in this case, when we're thinking about whether somebody constitutes as a qualified authority and whether or not we can say there's an appeal to unqualified authority happening here, recall that the appeal to unqualified authority was in fact one of the informal fallacies that we discussed earlier in the semester. We have to ask questions about their competence. In this case, what I'm raising in sort of suggesting that there's a possible defeater for this argument is not anything about whether the mushroom is safe. We don't even have to know anything about whether the mushroom is safe, but that might be a strategy for defeating the argument. Instead, what I'm asking are questions about the competence of the person in question. Does their possessing a PhD in Middle Eastern Studies grant them with what we could regard as competence with respect to judging the safety of eating certain mushrooms? And the answer seems to be, well, not exactly, right? Maybe they're a mushroom enthusiast who spends their time studying mushrooms outside of the context of being a professor of Middle Eastern Studies, but we don't have that information in front of us, and so they might have authority, but they're not drawing on the right kind of information for their authority. Moreover, this kind of pushiness that they're a doctor and that gives them credibility might be a basis for questioning their sincerity as well. And so you should consider what the circumstances might be under which we would say that in fact this person's being insincere. Okay, so let's look at the next one. Ann Carver insists that the Holocaust never happened. Since she works for the History Channel, I'm inclined to believe her. So the conclusion is that the Holocaust never happened. The reasoning for the conclusion is that Ann Carver says so. right? And so the question then again is, well, we could always construct the rebutting defeater, which is that by several other accounts and by, sort of knowledge we have of history and what happened at certain points in history, a Holocaust happened. And so we would need to be able to find the relevant historical sources and authorities that we could use to defeat Ann Carver's claim, or to defeat the conclusion of this argument. But we could also try to find the undercutting defeater and see whether we can show that there's some way in which we can doubt Ann Carver's competence or sincerity with respect to the material in question. And I think one clear way is to think about whether working at the History Channel grants someone with the competence required to be able to say things about history. And the answer is not straightforwardly yes here, right? Like the History Channel is a large organization. They have lots of people working for them. They have accountants, probably. They have producers. They probably have a certain number of executives, and none of these people are necessarily trained historians. And so once we take that into consideration, it becomes clear that, well, Ann Carver might not be someone who's in a relevant position just because they work for the History Channel, right? And even if somebody responds that, well, maybe she's a host on the History Channel, and so she's talking about the history, that still doesn't guarantee it, right? Because there are so many shows on the History Channel where the hosts aren't necessarily people who have competence with history. So even if we regard her in the context of other hosts like herself, we don't have enough evidence to know that she is competent with respect to the subject matter. So we could delve even deeper. We could try to look at her qualifications and her background. But right now, at least for the argument as stated, things are not looking good as far as whether it's fallacious or not. It looks like it's a fallacious appeal to authority, or an appeal to unqualified authority. All right, so next, this third one. I've been fixing this kind of computer for 20 years. You'll have to trust me when I say your motherboard is shot, right? So let's assume that it's true. And then let's assume the conclusion seems to be that the motherboard is shot, and the premise seems to be, well, it's because I say so, right? And so their authority is being, they're basing their authority on the fact that they've been fixing these kinds of computers for 20 years. And let's assume that that's true, right? They've been fixing those kinds of computers. That would seem to provide them with the position of being an authority about that kind of computer. And if so, then this looks like an appeal to qualified authority. And so we need to be careful when we're considering these things, because there may be context we can add that shows that conclusion may not follow, or at least is not strongly supported. But if we just take the information for granted here, it looks like it's an appeal to qualified authority. Of course, you should think about the different circumstances that might lead to the conclusion being weakly supported. I think it's important to think about those kinds of cases and just think about whether, in fact, we have reason to believe that those defeaters might actually be real defeaters. Those potential defeaters might be real defeaters. Okay, so let's look at the next one. Recall it asks whether the following are ad hominems or reasonable attempts to vet sources. So the first one says, you say that the oil and gas industry doesn't need to be heavily regulated, but you work for an oil company, so I'm not going to take your word for it, right? So on its face, I'm going to get into some details that might matter here, but on its face, this looks like a straightforward ad hominem. We're simply showing that because this person's complicit in being a part of the oil and gas industry, that we shouldn't believe them. This has kind of the feel of a tu quoque argument that we talked about before, because remember we talked about abusive ad hominems and ad hominems tu quoque. And the idea is like, well, look, you work for these people and you're saying things that satisfy their interests, so what you're saying is probably not true. And yeah, so on its face, it looks like it's an ad hominem. There might be a way in which it's a reasonable attempt to vet sources, and that might depend on what we can say we know about the oil and gas industry. In this case, the oil and gas industry might include people who are generally insincere, and if you know, if there are a sufficient number of insincere people in the oil and gas industry, which I don't know, this is just a way that could happen, then we might have reason to believe that people who say things about how the industry should be run are doing so with not from an objective point of view, but from the standpoint of what they regard as is in the interest of the company that they're working for. So in that case, then we might conclude that this could be an attempt to vet sources, but I think it's more likely just a straightforward ad hominem. So let's look at the next one. You've been arguing that we have no moral obligation to give money to the poor. I don't know exactly where your argument goes wrong, but you're obviously a selfish jerk. There must be something wrong with your argument, even if I can't say exactly what. So in this case, it looks like a pretty straightforward ad hominem. The conclusion is that the argument must be flawed, right? And it's because they're a selfish jerk. And whether that's true or not, maybe this person's just a really smart, selfish jerk and came up with the argument that leads to this conclusion. And so we have no obligation to help to give money to the poor. You know, and a lot depends on the surrounding details here, but given the structure of what's here, that there's a blanket appeal to that person's being a selfish jerk and a willful denial that, or I guess a willful kind of claim to the idea that in fact, there must be something wrong with the argument because they're saying it, kind of suggests that there's just a straightforward ad hominem here. So there you have it. Okay, so. All right. Now we're going to jump into the probability theory stuff. And sorry about that. And what I'm going to do is I'm only going to go in part of the way today. I want to introduce you, I want to motivate and kind of introduce some of the basic ideas behind probability. And what I want to do is kind of give you a sense of why we should care about probability, particularly in the context of inductive arguments, and then introduce you to some of the basic symbols and formal stuff we'll be using to talk about probability theory in the coming lectures. So, why probability? This up, there we go. All right, so I don't know why it starts there. So, particularly in science, scientists are in the game of collecting data. Usually the data they try to collect is oftentimes statistical in nature. This is especially true of the social sciences. And they try to collect statistical data for the purposes of trying to find out how to relate certain variables to each other in really large, complicated populations, right? So if we're examining huge populations of human beings, they're extremely complex, lots of things influence them, and statistics are seen as a way of trying to get past all the noise and to try to find what the deeper trends are in any given system that we use statistics to investigate. We can break down our statistics into broadly two categories. We have purely descriptive statistics, and then we have inferential statistics. Okay. Descriptive statistics are those statistics that we use that try to present informative claims about a population or about a sample, right? So if I want to, for example, present you with information about class averages, then I'll be then I take the class as a sample, and I calculate the relevant average, maybe using my Excel spreadsheet, and I say like, hey, the average on this quiz was an 80%. And depending on the context, that might tell you, well, hey, this quiz went especially well, or this quiz went especially poorly, right? Depending on the situation. But nevertheless, the descriptive statistic here is supposed to be something that's very informative. It's supposed to be helpful to us as far as trying to help us further certain goals or aims, or to sort of know certain things about the population. So notice here that the statistics are not being used to draw any further statistical conclusions. Instead, all we're doing is we're making informative observations about the population. So if I collected you all and I said, let's record everyone's average height, maybe that would be a descriptive statistic that might tell us something about, say, like certain demographic groups in the class, right? Where certain trends are in the class, without necessarily telling us that we can perform any further statistical inferences from that information. On the other hand, inferential statistics are very much about trying to give us a way of inferring further information from the sample that we possess. So one thing you might want to do is look at a difference between the kinds of claims we might try to formulate using statistical information. So the first claim we might want to try to, so for example, a descriptive statistical claim might be just like point blank the number of smokers in America. And that could be important because it could tell us about the prevalence of smoking in the population, right? It might, especially if we already think that smoking is a problem or problematic behavior, learning that it's widespread could be very informative. So that would be a really important role for a descriptive statistic to play. On the other hand, we might try to learn more about a population on the basis of other information that we possess about it. So the second claim that I have listed here says that the chances of getting lung cancer, states something about the chances of getting lung cancer if one smokes. And this would be a kind of inferential statistic, right? What we would want to be able to do is look at all the people who smoke and then ask what the chances of that group of people, what's the chance of being a person who gets lung cancer if you're one of those people who smokes, right? And in that case, what we would be doing is we'd be using our statistical information to draw further statistical conclusions. And so this would be a kind of characteristic inductive inference. And so ultimately what we're going to do is we're going to move towards looking at more inferential statistics, and a lot of what we're going to be doing, especially when we get to what's called Bayes' theorem in this section of the course, will be focused around trying to show how we can model these kinds of inferences as inductive arguments and how to formulate fairly precise calculations about probabilities using this information. Okay, so a probability. The first question I want us to ask is, well, I mean, what is a probability? You all are probably have some associations that you have with the word probability, maybe like chance or luck or something like that. And maybe if you've taken a low-level statistics course, have had some acquaintance with basic probability theory, and you might have done things like, well, ask like, hey, what's the probability of flipping a coin and having it land heads after so many tosses, or something along those lines, or what's the probability of rolling two dice and a pair of dice and getting a certain result. The first question I want us to ask is, well, what does it mean to say that something has a probability of occurring? That is, what exactly is a probability? We have to try to locate it somewhere in the world, presumably. And I'm going to go over two answers, and just so you know, there's kind of a debate and a bit of disagreement in philosophy, especially about exactly which of these is the right approach to take with respect to which of these is the right approach to take. But I'm not going to present it as a disagreement here because the disagreement's a little esoteric in some ways. And what I instead want to do is kind of motivate different interpretations you might have and then suggest to you which interpretation it is that we're going to favor. So one way to interpret what a probability is just to say that a probability is a frequency, right? And what I mean by that is just what the word says, that we observe something happen, like we have a number of trials, like a number of coin flips, for example, and we observe something happen in that population or in that set of trials a certain number of times. So we flip the coin 100 times and we get 48 heads and 52 tails. And what we ask is like, okay, what's the probability of getting tails? Well, it's 52 over 100. Maybe that's what a probability is. It's just the raw frequency of the event happening over the number of trials that we're examining. And that's certainly one way to go, right? One problem with this is just that if you go with this strict of an interpretation of what a probability is, you'll end up in situations where it seems like you have difficulty accounting for things like what's called sampling error, which is that strictly speaking, events, the way they actually happen, don't always record or reflect exactly what the probabilities of those events are. So, you know, it's unlikely, but you could flip a fair coin 50 times and get heads all 50 times. That's certainly a possibility. And so identifying probabilities with frequencies might run into the issue that it's not always the case that the actual frequency of an event records exactly what it is, what exactly the probability of that event is. But either way, this is one way to interpret it. The way we're going to interpret it is that we're going to treat a probability as kind of like a certain degree, what we're going to call a degree of belief or a credence. It's strictly speaking how much you believe the claim, right? And so whenever you see the word probability, whenever you see what we're talking about in the context of a probability, what we're going to do is we're just going to say like, hey, what we're talking about here is how much you should believe something. Okay, what should your degree of belief be? Okay, so that's the idea here. Okay, so with that said, we're going to start slowly moving into the formal calculus that we're going to use for describing probabilities. It's not that complicated. If you know how to do basic addition, subtraction, division, you should be good to go. There are going to be a few symbols that we need to be able to know the meaning of before we can move into the exact rules for probability. And so where I'm going to end today is I'm just going to give you a basic definitions of the different notation that we're going to use. So I'm just going to go from top to bottom or from column to column really, and give you a sense of what each of these means. And so I want to preface this by saying that for these definitions, I'm treating the letter variables as events, but we can also treat the letter variables as statements. And you can, for our purposes, you can mostly freely translate between the two. And so I kind of want you to be able to sort of subjectively practice with that, okay? So the first thing is that you'll get something that looks like a function. And so like where we see PR with A in parentheses, what we mean is that all we mean to convey with that is the probability of A's occurring, or if A is instead a statement, the probability of A being true. Okay, so A is going to be an event or a statement. If it's an event, like it could be something like landing heads, the probability of landing heads or the probability of landing tails, you can translate this over to a statement by saying something like the probability of its being true that the coin lands heads, or the probability of its being true that the coin lands tails. Okay, right? So we're going to take it that events and statements can enter into disjunctions. They can be, we can insert a V between different variables, and that V will tell us, will be a certain kind of relationship that the two have. In this case, it's just or, right? The probability of A with the little vb just means the probability of A happening or B happening, or if they're statements, the probability of A's being true or the probability of B's being true. Okay, so the or works a lot like the way we've discussed ors before. We can think about things in terms of exclusive and inclusive. By default, let's read it as inclusive unless I give you reason to believe otherwise. But there you have it. Next, we have this ampersand, which is the probability of A and B, which means the probability of A happening and the probability of B happening, right? So this is a conjunction. And I want you to remember these rules because they're going to come up in the names for the rules that we're going to use in the context in the context of calculating probabilities. So there are going to be disjunction rules and there are going to be conjunction rules. So you want to remember the difference between the two. Okay, so the idea here then again is that we can interpret it in terms of events where we have the probability of A happening and the probability of B happening, so where they happen at the same time. And we can also just think about this in terms of statements where it's the probability that A is true and B is true, right? So there you go. The second to the last symbol is this tilde. And when you slap a tilde in front of a sentence variable or a variable as we have it here, then what you're doing is you're saying either that you're asking either about the probability that the event does not occur or the probability that a statement is not true. So the tilde is what we call a negation. And there will be a negation rule, so you want to make sure you're familiar with that term. So in this case, again, all we're saying is that when we put a tilde in front of a letter, we're saying that we're talking about whether the opposite of that statement is true, right? So if I want to say the probability that the coin lands heads, if I put a negation in front, then I'm saying that I'm asking about the probability that it is not the case that the coin lands heads, or in this case, that's equivalent to the coins landing tails. Okay, so that's the negation. The final symbol is this little bar that we'll be able to put in between our variables, which means that, which just means if. The probability of A if B. In terms of statements, it would be the probability that A is true if B is true. In terms of events, this would be the probability that A happens if B happens. Now, I'm going to trade pretty freely between this event and statement talk. Ultimately, when we get to Bayes' theorem, I'm going to want us to think more explicitly in terms of statements, because arguments are collections of statements. But some of the examples I'm going to give you as we push through things are going to feel more natural if we talk about them in terms of events. So I'm drawing the distinction now between events and statements so that you can get a feel for it and won't be too confused later on when you see us trading between the two. Okay, so those are the different symbols we're going to use. Next time, what I'm going to do is I'm going to begin to introduce you to the different rules, the basic rules of probability theory, and we'll start going into forming calculations, and then we'll prove what's called Bayes' theorem as well. Okay, well, thank you very much. Let me know if you have any questions, and I'll see you next time.